Now I want to do one more example of a Riemann sum, this time not using a data and not using a table, but this time I wanted to use a function. So in this case, the function that I want to use is cosine of x. Now I'm going to do it over the range, over the interval of 0 to pi over 2. That's going to be my domain in this case, from 0 to pi over 2. Now notice this is radians, so please make that adjustment in your calculator before we get started. Now, we're going to use n equals 4 subintervals. So we're going to have 4 different rectangles that we're going to use in this case. So here's what we're going to do. Like I said, the first thing I always try to do to give myself a better sense of what this is going to look like, what this Riemann sum is going to do, I always try to sketch a picture. So I'm going to draw a picture of cosine of x on my graph. Now, if you remember anything about cosine of x, at 0, it starts at the very tippity top of its roller coaster. It starts at 1, which is its amplitude. So as it starts up here, it slowly goes down and then it increases. And it will have an x-intercept at pi over 2. Now, to remind you, at pi over 2, that's the x-intercept. It is going to keep decreasing all the way until it gets to pi comma negative 1. And then it's going to go right back up and hit 3 pi over 2 comma 0, which is the other x-intercept. And then it's going to keep going back up. And remember, cosine and sine repeat themselves very, very often. So I don't really need all that information because, again, my domain, the interval that I want to worry about is from 0 to pi over 2. So here's what I need to do. I need to chop this up into 4 different sections. So the question is, how am I going to divide up 0 to pi over 2 in 4 sections? Well, all I got to do is, if I'm starting at 0 and going to pi over 2, is divide pi over 2 by 4. That's going to help me out a lot. If you do that in your calculator, if you do it in your head, you should get pi over 8. So the first one's going to be at pi over 8. Then I'm going to go to 2 pi over 8, which is just pi over 4. Then I'm going to go to 3 pi over 8, which doesn't simplify. So there, I'm going to be able to have 4 rectangles. One here, 2, 3, 4 rectangles. Now, we're going to do 2 different Riemann sums here. We're going to do a left Riemann sum, and we're going to do a right Riemann sum. So let's do the left one first. If I'm looking here, between 0 and pi over 8, the left number is the 0. So I'm going to use cosine of 0. Then, if I want to do the next one, I'm going to do pi over 8. So I'm going to do cosine of pi over 8. Then for the next one, between pi over 4 and 3 pi over 8, I'm going to use pi over 4. For the last one, I'm going to do 3 pi over 8 to pi over 2, so I'm going to use that 3 pi over 8. So, I'm going to plug these numbers in and see what happens. I'm going to do my best. Make sure, again, your calculator's in radian mode. So cosine of 0, we should already know is 1. Cosine of pi over 8 is a really, really, really long number. 0.92387955325. I'm not going to ask you to write all those decimals. You might want to just write a couple. I'll probably round off at 3 decimal places, 0.924. All right, then I'm going to do pi over 4, which is the square root of 2 over 2. Again, I'm going to try to round that at 3 decimal places of 0.707. And then I'm going to do the last one, which is 3 pi over 8. And again, round off at 3 decimal places of 0.38. And then that's 2/6, so I'm going to round that up to 0.383. Now, I'm going to go back to trying to find my Riemann sum. The question is, how wide are my rectangles going to be? In this case, my rectangles are pi over 8 wide. That is its width. So, I'm going to go to try to calculate my Riemann sum. Let me repeat again. These are going to be my left numbers. These are my heights. And I'm going to use the pi over 8 as its width. So let's do the first one. So, pi over 8 is the width times 1. That's its height. Then I'm going to add pi over 8, which is the next width, times 0.924, which is the next height. Then I'm going to do another pi over 8, because that's the next one, which is 0.707. Now, like I said, I'm not doing a great job because I am rounding here, but I am going to get a decent estimate of this. So, we're going to do the last one, which is pi over 8, which is 0.383. All right? I'm going to go ahead and start trying to do some math on this and see how far I can get, okay? So, pi over 8 times 1 plus pi over 8 times all that other stuff. 0.924 plus pi over 8. I know it takes forever to type everything in the calculator. It's just terrible. Worst thing ever is having to type stuff in the calculator. Slows me down, right? That's why it's good to know your mental math. All right. So when I type all that stuff into the calculator, my calculator gives me a nice, pretty answer, which is 1.18, and it rounds it. It rounds it off way down the line. I'm going to go ahead and round off at 3 decimal places just to be consistent, which is 1.184. Okay. So that's my left estimate. Now, if I wanted to do a right estimate, which is the right Riemann sum, I'm going to go ahead and try to use the right numbers in this case. So instead of using the 0 for the first interval, the pi over 8 for the next subinterval, pi over 4 for the next subinterval, and 3 pi over 8, I'm going to use the right number of those two. So not start at 0, but start at pi over 8. And all I have to do is just add in one more number and just plug in pi over 2, which we know is 0. We should know that cosine of pi over 2 is 0. So like I said, we're not going to start at 0. We're going to use these numbers instead. Now notice this is going to give me a slightly different estimate. Now before we had a left estimate that was lower than the right estimate. In this case, our left estimate is going to be bigger than our right estimate because we got rid of that 1 right off the bat. So here I go. I'm going to go ahead and start calculating the right one. Remember, this was the left Riemann sum. We use the left numbers. All right, so here I go. Pi over 8 times that 0.924 plus pi over 8 times 0.707 plus pi over 8 times 0.383 plus pi over 8 times 0, which means all I got to really do in my calculator is delete that first term, that first one, which is pi over 8 times 1, because everything else at that end, that pi over 8 times 0, well, that's just 0. So let's see what happens. So, whoop, I'm making silly errors over here, Mr. Harold. All right, let's see what happens. I got 0.79, and I'm going to round that up again, 3 decimal places to 1. So there's my right Riemann sum. Okay? So, hopefully you guys have a better idea of what we're talking about now. Again, you notice some of the common things. It's always good to draw a picture. Pictures help a lot. And number 2, tables make it easy for me to digest the information and to eventually get to the multiplication. Everything makes it nice. Hope you all have a great day.